Okay, so now I want to talk about this section 3 from chapter 6, and we bring it up again because when we talk about atoms, different elements, compounds, molecules, and chemical reactions, this is going to be very important with metabolic pathways, and which we'll talk about later, some really important ones in the form of cellular respiration and photosynthesis. And we'll see that in these pathways, enzymes are very important in facilitating them. All right. Now also, with these metabolic pathways, these chemical reactions, energy is an extremely important phenomenon that we have to think about. So let's just go through some of the forms. There are many, many forms of energy and ways of thinking about energy, but let's just talk about a few of them here. And so, as you've learned in the past, you've probably, of course, heard of potential energy and kinetic energy. And potential energy is what we would refer to as the energy of position. So it's the energy that is just inherent in an object from its position in space. And by space, I don't mean necessarily in outer space, but just its position. Every object has a certain amount of energy because it is. Now, the kinetic energy is, sometimes we describe it as the energy of motion, or you can think about it as the amount of energy it takes to move an object. Okay? And these two together comprise what can be thought of as mechanical energy. So it's the sum of the positional energy and the energy of motion. It's these things together. Okay. All right, we can also talk about chemical energy, which is really important in biochemistry, obviously. And it's the energy that is found in, whoops, what am I trying to write here? These chemical bonds. The covalent ionic hydrogen bonds, all these bonds, and it's basically the energy that is inherent in matter because of these bonds. All right, then we have electrical energy, which is energy that's due to the flow of electric charge, or the movement of charged particles. Charged particles, for example, electrons. The movement of electrons in copper wires is a form of electricity, and what we most often think of. Now we'll see these two kind of work together in many living systems, in that, as we'll see, electrons are moved around in certain reactions, specifically cellular respiration, photosynthesis. And so that's a way of moving energy. It's essentially what's described as sort of electrochemical energy. And so those two can kind of be combined in that way. All right. Then we have radiant energy, which is the energy of what we call electromagnetic waves, and it's measured on what's called the electromagnetic spectrum that we'll look at specifically when we talk about photosynthesis. And one way of thinking of it is you can think of it as basically light, which is basically consists of photons moving through space. And this can also be thought of as a wave with different frequencies, So it's sort of both a particulate form, the photon, and a wave. And again, these waves come in different frequencies, or they have different wavelengths. We'll talk about that as well when we talk about the electromagnetic spectrum. And a sort of form of radiant energy is what we would refer to as thermal energy. Let's rewrite that as thermal. And this essentially is part of potential and kinetic energy, and in particular the part of that that gives something its temperature. And it's due to the movement, the random movement of the particles in that matter. So the molecules in that matter, they have sort of this random motion that gives that object a certain temperature. And related to this is heat, which is when this thermal energy is transferred sometimes from the object itself just out into space, or from one object to another. When it just goes out into space, this is sometimes described as just radiant energy. It's just sort of being given off. And here, this is due to what's called conduction. So when you put your hand against a warm object, some of that heat is conducted into your hand. When you put your hand against a cold object, some of the heat is drawn out of your hand and it conducts into that cold object. Okay? Alright. And so, again, we have metabolic pathways that we'll study some more in detail. And you can cluster these metabolic pathways into sort of two general types. Ones that are exothermic and ones that are endothermic. The exothermic ones, as is shown here on the left, basically we would say they release energy. And the endothermic ones, basically, they take in energy. So as you can see here in the exothermic reaction, you've got your reactants. And in any kind of chemical reaction, you have reactants that react to form products. And so in your exothermic reaction, the reactants have more energy than the products. So there's a certain amount of this energy, again, which is released, given off, made available to do some kind of work. Alright, in the endothermic reaction, the reactants have less energy than the products, and so this reaction has to take in energy in order to form these products. The products will be molecules that are typically more complex. It's taken energy to build them up from simpler types of molecules. Okay. These exothermic reactions are sometimes described as being spontaneous because they will, over time, just happen. Because the natural order of things is to go from sort of a higher energy content to a lower energy content, from a more ordered state to a less ordered state. However, just because it's spontaneous does not mean it happens quickly. It can sometimes and often does happen very slowly. So, and what keeps them sort of just happening spontaneously really quick? That's what's called the activation energy here. It's the energy required to get the reaction going, and in some cases that energy can be somewhat significant amount. It's demonstrated by this little hill here. Okay, so that really slows the reaction down. Now, what if you have a reaction that your body wants to carry out? You have some higher energy compounds stored inside you and you want to release the energy in them so you can do some kind of work. Well, that's where our good friends enzymes come into play, because the enzymes, what they do is they lower this activation energy such that the reaction becomes much more spontaneous, and it happens. The enzyme, we would say, catalyzes or facilitates the reaction. Okay, speeds it up. Now, these reactions as well will require enzymes to help facilitate them, but it doesn't do that by necessarily lowering the activation energy. Lots of energy is needed to be put in to get them to work. Alright, so again, enzymes can break things down, they can build things up, but they do that by having what's called an active site, which is this spot on the molecule where the substrate or substrates get together, and the enzyme causes the reaction to occur, either breaking them apart, in this case taking one thing and breaking it into two, or in the case of synthesizing something, taking two substrates and making a single product. Either way, the enzyme grabs onto it on its active site, puts these things together or breaks them apart, a physical process facilitating the reaction. As is mentioned in the book, there are things that can affect enzymes, different conditions, and so as you read there, and you all have figured out, and with our experiment we did, of course we know the amount of substrate can affect the reaction rate. The amount of the enzyme, gosh, what is that supposed to be? Enzyme can impact the reaction rate. Something like temperature, the pH of the solution. We mentioned how in your stomach it likes a really low pH, and so those enzymes like it to be very acidic. Also, sometimes enzymes can be inhibited by the presence of other compounds that basically block the active site, and so they keep the substrate from bonding with the enzyme, and the enzyme can't do its job, and these are known as these inhibitors. And I mentioned how sometimes certain types of pesticides operate this way. They keep enzymes in the pest organism, this insect or whatever, from doing their job, and that of course compromises that insect and kills it. Now, one other thing you should sort of be aware of is what's called, it's mentioned at the very end of this section, is what's called feedback. And with feedback, what happens is if you have a chemical reaction in which A and B are being used to make C, and there's this particular enzyme that facilitates this reaction, what can happen is C, the product, can actually serve as an inhibitor of the enzyme, and that is, this is what's called feedback. It's slowing down the process, such that if you have lots of the product around, that's going to slow the reaction down because you don't really need to make much of it. But if you have very little of the product around, there's less inhibition and the enzyme does its job and you carry out the reaction. This feedback, or what's called feedback inhibition, is very important in living things in controlling these reactions. Again, if you've got a lot of the product around, you don't need to make it. There's no need for the enzyme to do its job. This will serve as an inhibitor. If there's not much of this product around, you want to carry this reaction out, then the enzyme will not be inhibited and it'll do its job and convert A and B into C. Okay? Ask me about that in class if it doesn't quite make sense. Okay.